Hey guys, Mr. Riz here to help you out with the first day of the 3.3 guided notes. So what we're going to be looking at here is specifically on a function, whether it is increasing or decreasing. Now we can kind of do this if we just visually look at the graph and the function is increasing when it's going up and it's decreasing when it's going down. But what we're trying to do is to be able to evaluate that or figure that out without graphing the equation. And the way that we can do that is by using what's known as the first derivative test. And we say it's the first derivative test, not just the derivative test, because there'll be a second derivative test later on. Okay, so here's the fancy definition here is a function f is increasing on an interval when any two numbers x1 and x2 in the interval that x1 is greater than x2 and it implies that f of f1 is greater than f of f2. Means here, like if we get 2 points like on this point, here's x1, here's x2, and x1 is before x2. If x1 is below x2, that means the function's going up. And then kind of conversely here, decreasing would be the opposite of that. If x1 comes before x2, but x2 is bigger than or x1 is bigger than x2, then the function's decreasing. And we can see this like as typically we look at the graph here and the graph would be going down. So we'd say it's decreasing. If the graph is going up, it's increasing. And then if it's straight flat, we'd say that's constant. Now, how does this relate to the derivative? Well, if we know that the derivative of that point there, of derivative of all those x values here, all those would always have to be a less than 0 or a negative number. So as long as the graph is going down or the derivative is negative, we have a decreasing function. If the derivative of x is greater than 0, or aka the derivative is a positive number, the graph would be going up and it'd be an increasing function. And then if the derivative is ever equal to 0, we'd have a constant value there. Okay, so what we're going to do here is we're going to look at or try to figure out where do we have the graph going up or down. And so the first thing we're going to do is to do the first derivative test. So we need to find, we'll make some steps here. First thing we're going to do is we're going to make a note here, step 1. We're going to find critical numbers. Now these critical numbers is when f prime of x equals 0. Okay, so here we go. Let's find f prime of x. So this equation here, the derivative of x cubed is 3x squared, and the derivative of 3x or 3 over 2x squared is minus 3x to the first. All right, so we're going to set this equal to 0. Okay, to solve this problem, we would have to factor out the 3x and make this a x minus 1. And we actually get two critical numbers in this problem. We get one here, which, all right, if we set that equal to 0, 3x, we could divide 0 by 3, and we get 0. And if we set this one equal to 0, we get x equals 1. All right, now what I want you guys to do for step 2 is we're basically going to make a number line. Make a number line. Oops. Keyboard kind of jumped right there. Number line. All right, so what I'm going to name this number line is f prime of x. And we're going to put our critical numbers on the number line, and that's it. All right, so we have 0 that comes before 1. All right, then what we're going to do for our third step is we're going to pick numbers in between. Oh, I forgot the one there. Pick numbers in intervals and check to see if f prime of x or f prime of c is positive or negative. Okay, so let's go ahead, pick a number in this interval. Now this interval is between negative infinity and 0. So we can pick any number, and I'm going to pick negative 1. So what's f prime of negative 1? So if I plug negative 1 into here, we would get, let's see, be 3 times negative 1 squared minus 3 times negative 1. All right, that'd be a positive 1 times 3. That's 3 plus 3. Okay, that's 6. 6 is a positive number. So that means everything on this graph between negative infinity and 0 is a positive derivative. Means the graph would be going up. All right, now let's pick a number in between 0 and 1. And so an easy one is like 1/2. So what's f prime of 1/2? So what's 3 times 1/2 squared minus 3 times 1/2? All right, half is, let's see, a quarter times 3. So we got 3/4 minus 3/2. Okay, so that would be like a negative 3/4, I believe. Or it doesn't really matter what the value is other than what is the answer, and that would be a negative number. So that means it's a negative derivative in between 0 and 1. So that means the graph is going down. And then we got to pick another number in this interval. So we'll pick another number between 1 and infinity. So we can pick any number. So we could pick like 10. What's 3 times 10 squared minus 3 times 10? Oh, I'm kind of, face is running out of room there. So let's see, that's 300 minus 30. Okay, that's 270, which is a positive number. So that means the graph is going up. So this is going to be good enough for us. Now, AP kind of has to write in the proper format here where they actually state the intervals as values in between such and such. But what I want you guys to do is if you make this number line, you should be able to look at it and kind of visualize what's going on. The graph is going up, then it goes down, and it switches right at 0, and then it goes down to up. Now we can kind of make another connection here. What we can think about, if this graph goes up, then at 0, it switches to going down. That means right at 0, that would be a maximum point. And then here at negative, or at 1, if the graph was going down and at 1, it switches to going up, that would be a minimum point. So we can actually find our extrema, which are mins and maxes, just by doing the first derivative test. Okay, so we're going to take a lot of time going through this, making sure we understand kind of what all these values means and the different things that could happen. Okay, I think that looks good right there. Let's go ahead and try another problem. In fact, well, you know what we should do here before we do another problem? Let's verify our thoughts. So we think it goes up, down, and then up, and there's a change at 0 and a change at 1. Let's look on a graphing calculator here just to verify that. So let me pull up the graphing calculator, and it's the first time I'm doing this today, so you know it's going to take forever. So let me pause the video while this loads up. All right, so we got a graphing calculator here. Let's double check this. Got a graph already there. We got y equals, what was it? X cubed. And then we had minus 3 over 2 x squared. I think that's what it was. Graph that. All right, right here at 0, it switches from going up, and then at 0, it switches to going down, and then at 1, it switches from down to up. So we were exactly right. It goes up, down, and up. So remember, our goal in this whole chapter is try to look at graphs without using a graphing calculator. We just use the graphing calculator to make us feel better about our answer because there's so much math that we do here. All right, so let's go through this next problem here. All right, I might want to change this to x plus 9x to the negative first. Because when we take the derivative of this equation here, x goes to 1, and then 9x to the negative 1 goes to a negative 9x to the negative second. So the derivative would be 1 minus 9 over x squared. So to find the critical numbers, we need to take that problem, set it equal to 0. All right, so I'm going to move that over here. So we got 1 equals 9 over x squared. And I'll make this a fraction here so we can cross multiply. So 1 times x squared is x squared. 1 times 9 is 9. And then we take the square root, we get plus or minus 3. So we do have two critical numbers here. One's at negative 3 and one's at positive 3. Okay, next let's go through and actually we do have another critical number here. Forgot to name. The one thing we always want to do, not only where the derivative would equal 0, but we would have another critical number, is where does the derivative not exist? Since we have this negative, or this x squared on the bottom, we also need to make sure that x squared does not equal 0. Because if we have this equation, we can't have a fraction with a 0 on the bottom. So that basically means x cannot equal 0. So we also need to add that to our chart. So I got a little ahead of myself here, but a couple things that we need to do with critical numbers. Make a note with the critical numbers. Typically, it's when the derivative would equal 0 or when the derivative does not exist. So we need to check both of those. Now, when we have a normal polynomial like the one above, we don't really need to worry about this. Typically, you need to worry about when it does not exist when you have fractions. So when you ever have an x on the denominator, you always need to double check that here. Okay, so let's pick some numbers in these ranges here so we can plug in. So I'm going to pick a number like f prime of, let's do -4. What's 1 minus 9 over -4 squared? Okay, so if we plug that in, that's 1 minus 9 over -4, that's 16. I don't know what this is, but I know that number is less than 1, and if I take 1 minus that, we would get a positive number. So that means the graph is going up. All right, now let's pick a number in between -3 and 0. So easy number like that is -1. What's 1 minus 9 over, we're just going back to the derivative here, plugging in numbers, -1 squared. All right, so that'd be 1 minus 9. 1 minus 9 is -8, so we got a negative number. So that means the graph is going down. So it's going up and then switches to going down at -3. Let's pick a number in between 0 and 3, like 1. That's easy because that's 1 over 9 minus 1 squared. That's also 1 minus 9 or -8. So that means the graph is going down again. And then what we got here is let's pick a number bigger than 3. It doesn't matter. We'll do 4 since it makes it easier here. 1 minus 9 over 4 squared. 1 minus 9/16. That's some positive number. So that means the graph is going up. So the graph goes up, down, down, up. So we probably can say like right here that -3 is a max because the graph goes up and then it goes down. And then right over here, 3 we can say is a min because it goes down then up. What would 0 be? And this can happen. There's a couple different situations of like what could cause the graph to go down, have a critical number, and then go down again. So let's look at the graph to kind of think about like what that would mean. Now, some of you who are pretty good with number sense can probably think about, okay, if that's the 0 on the denominator, what that would mean on a graph. But if not, let's go ahead, take out our graphing calculator here and type that equation in. We got x minus 9 over x. Or was it minus? Or no, it's plus. That'll make a difference. All right, we graph this here. All right, we can see the graph goes up and then it goes down. It looks like right at 3 is where it switches, and then the graph is going down and then up. So 0 was our other critical number, which is the y-axis here. You can see that's where the graph jumps. So that's our vertical asymptote. So sometimes when we look at critical numbers, they can be mins, they could maxes, they could also be a vertical asymptote. And there's one other type too. Okay, let's keep this going here, do some more practice problems. Let's throw some trig at us. Now, when we're specifically looking at trig in this class, we're just going to look on a closed interval. So what a closed interval does is they give us points. So that means our number line is automatically going to have 0 at the beginning and 2 pi at the end. We're not going to go from like infinity or anything beyond. But we're still going to go take the derivative here. Let's see, x goes to 1, and then minus 2 cosine. The derivative of cosine is negative sine. So minus 2 becomes plus 2 sine of x. Okay, so let's set that problem equal to 0 and solve for that. Okay, 1 does 2 sine of x. We subtract 1 over equal -1. Divide by 2. 1 does sine x equals -1/2. So when we take the inverse here, x would equal the sine inverse of -1/2. So take out a unit circle, try to see where the sine, which is the y, equals -1/2. Let's see, that would be at 7 pi over 6 and 11 pi over 6. All right, so we mark those on our part here. There's 7 pi over 6. Now, we don't have to be like super close with the units and distancing here, but we're just showing like, okay, it's going to go either up or down, then up or down, or then up or down. So what we need to do now is we need to take numbers and plug them into the derivative. So let's pick a number, and I would pick a number on the unit circle that's easy to plug into. So how about pi? What is, okay, y prime of pi? If we plug that in, what's 1 plus 2 times sine of pi? Let's see, the sine of pi, sine is y, that's 0. So what's 1 plus 0? Well, that'd be 1. So that's a positive. So that means the graph is going up. Right? Did I do that wrong? No, I think that's right. All right, next. Why does it feel like, okay, 0 minus 2? I feel like I did that wrong. We'll find out. I'll pause the video if I messed up. All right, now let's pick a number in between 7 pi over 6 and 11 pi over 6. Looking at the unit circle, it looks like 3 pi over 2 would be nice. So what is y prime of 3 pi over 2? What's 1 plus 2 times the sine of 3 pi over 2? All right, 3 pi over 2, the sine of that is -1. So what's 1 minus 2? That's -1. So we'd get a negative. So it goes down. And then let's pick a number in between. Now, there really isn't on the unit circle a number in between. So we can pick a decimal and plug it in with our calculator, or we can use some logic here. A sine function is a constant function. It's just going up and down. It's a wave. It's always going to alternate. All right, there's no jumps to it. There's no discontinuous point. So if we go up and then down, and then lastly, we'd have to end with up. So let's double check to see if we did this right. We'll take out our graphing calculator here. Let's see, what is x minus 2 cosine of x? All right, so the graph starts going up, switches to going down, and then it ends going up. And we're only looking from 0 to 2 pi, which is like 6 something, 6.28. All right, and that'd be about right there. Okay. So hopefully we're doing all right with this. So some guidelines with these things is what we want to do is locate all the critical numbers from A to B and use those to test. We then determine the sign of f prime of x. So we pick a number in the interval and we determine, like, is that sign positive or negative? And then we determine whether that's increasing or decreasing, whether it's positive or negative. And it's pretty easy. If it's positive, it's increasing. If it's negative, it's decreasing. So what we can also do too is kind of locate some relative mins or maxes. So if the graph is decreasing, then increasing, that spot there would be a minimum. If it's increasing, then decreasing, that would be a maximum. Now there's a couple other times where if we could have like increasing followed by increasing, excuse me. Right here is an example where the graph is going up. At this point would be a critical number because the derivative equals 0, and then the graph goes up afterwards. This is another type of critical number that we'll talk about later, but right now we'll call it a neither. All right, it's neither a min or a max. Just like a vertical asymptote is neither a min or a max. Okay, so let's take a look at the homework here. What you guys need to do for these ones is sometimes they give you these graphs here. And what I want you to do here is just visually looking at the graph. Now you can look at the equation to help you out, but can you make the interval here? So if I'm looking at this first graph here, okay, I can see right here a -1 would be a critical number. So I put a -1 on my chart here. Now the graph is going up, then it goes down. So the derivatives would be positive, then negative. And that's all you need to do. And then if you also want to say that this is a max, that'd be extra points there. So for each one of these graph problems, you're just going to make the number line here. Okay. Then for 10 and 12, you're going to go through and without the graph, see if you can take the derivative and find the critical numbers. Some of those might look a little specific, certain, like 12. Kind of looks familiar. And then 18, 20, 22, the same thing, except for they definitely want you to try to see what those mins and maxes are. All right, guys, that's pretty much it for this section. I will see you guys for the next day. If you have any questions to ask, if not, good luck. Have a good one.